Hello everyone. In this problem, we are having m rows and two columns. Means two is number of columns is two, but the number of rows can be m. M generally will be what do you call greater than two. Just a minute. Here m is larger than two. Means there are only two strategies for B, but A has got more than two strategies. So as usual, first step is to find out the row minima. We need to solve this particular game. So we'll adopt the same procedure to check whether there is any saddle point or not for this problem. Row minima, first row minimum is 4, then 3, then -4, -5. Then column maximum. First column it is 8, second column it is 7. So we have now maxi min value, which is the maximum of all the minimum values, that is 4, 3, -4, -5, which becomes 4. Then mini max value, which is minimum of all the maximum values, that is 8 and 7. So it is 7. So it is clear that maximum value is not equal to mini max value. That implies this game do not have a saddle point. This game do not have a saddle point. So that indicates, that implies that both players are adopting mixed strategies. Next step is to check for the dominance. Here we do only the row dominance check because columns, number of columns are already 2. So check for dominance basically for rows. Let's check that. Row 1 versus row 2. 4 is larger than 3, whereas 6 is lesser than 7. So no dominance found. Then R1 versus R3. 4 is lesser than 5. 6 is larger than 4. Again, no dominance found. R1 versus R4. 4 is less than 8. 6 is larger than -5. So again, no dominance found. Now comes R2 versus R3. 3 is lesser than 5, whereas 7 is larger than -4. Again, no dominance found. Then R2 versus R4. Second row and fourth row. 3 is lesser than 8, whereas 7 is larger than -5. Again, there is no dominance between these two rows. Then the last comparison is between row 3 versus row 4. 5 is lesser than 8, whereas -4 is larger than -5. Again, there is no dominance found between these two rows. That means dominance property is not helping us to reduce this particular matrix of 4 by 2 matrix, right? We are not able to reduce it. So we'll proceed with finding the expected payoffs for player B. Expected payoffs or expected payoffs for B value. Sorry, B player B. Because we'll be approaching this problem from B's perspective because B has got only two strategies. So we can able to plot it on a graph. So we will say the expected payoffs function to player B against various alternatives of player A and the values of expected payoff for player B are evaluated as below. I'm sorry. As below, considering Q1 equal to 0 and Q1 equal to 1. And what is all this Q1 and etc.? So first of all, we will have to define let P1, P2, P3, P4 be the probabilities of player A adopting his strategies 1, 2, 3, 4 respectively. Similarly, let Q1, Q2 be the probabilities of player B adopting his strategies 1, 2 respectively. So here it is very clear that if I add all these probabilities, it should lead to 1 because these are the available strategies for player A. So that sum should be 1. Similarly, here also Q1 plus Q2 should be equal to 1. Now, for our convenience, let us just write those probabilities here. Here, Q1, Q2. Just a minute. I need some sort of space. I think I should rub this and I will shift it to the next page. Sorry. Sorry. Let me put page numbers for. Yeah. Let Q1, Q2, Q3 be the probabilities of player B adopting his strategies. One, comma 2 respectively. And since there are only two strategies, the probabilities, if I add, it should give me 1. Right. Now let us create table for the payoff function and payoff values. We'll have, let's say, 5 columns, and then we'll have 6 rows like this. I'll merge this. Here we have A's alternatives. Here B's expected payoff function. Here we have expected payoff values if Q1 equal to 0 and Q1 equal to 1. Why do we take this? Because the minimum probability value possible is 0, maximum probability value possible is 1. And substituting 0 and 1 and finding the values will be much more easier than choosing any other values. For that reason, we are choosing 0 and 1. Then this is our line reference. Since these are all A's alternative 1, 2, 3, and 4, we'll give the line references as A1, A2, A3, A4. Now, how do we write the expected payoff function? I can first autofit this. Yeah. Now, going back to this table, we can write 4 times Q1 plus 6 times Q2 for the first alternative. So that I can write it as 4Q1 plus 6 times. See here, when you have this Q1 plus Q2 is equal to 1, it means that Q2 can be written as 1 minus of P1. So here I will write 1 minus of P1. And if I expand this, I will have 6 minus 2Q1. I'm sorry, here I should have written Q1, not P1. Here also Q1. So now if Q1 is 0, this will become 6. If this will become 4. Next payoff function, 3Q1 plus 7Q2. 3Q1 plus 7 times Q2 can be written as 1 minus of Q1. So this will be 7 minus 4Q1. Then third function is 5Q1 minus 4 times 1 minus of Q1, which will be minus 4 plus 5Q1 minus 4Q2. Okay, so minus 4, minus into minus, it becomes plus. So plus 9Q1. The last one is 8Q1 minus 5q2. So minus 5 times 1 minus q1. That will be minus 5. Minus or minus, it becomes plus. So it is 13 q1. Now let us substitute. This will be, if I put q1 as 0, this will be 7. This will be minus 4. This will be minus 5. Here it will become 3. This will become 5. This will become 8. Now we have the coordinates ready. We can now draw the graph. Here you may notice that in the q1 equal to 0, the least value is 5 and the highest value is 7. Here the least is 3 and highest value is 8. So we can have a graph like this. Since the negative value, least negative value is negative 5, I will put somewhere here the horizontal line. This is our origin 0. Sorry. This is our origin 0. Origin 0. 1. Actually minus 1, minus 2, minus 3, minus 4. Sorry. This will be minus 1, minus 2, minus 3, minus 4, minus 5. And then the highest value is 7. Here highest value is 8, so I should literally extend it. Okay. 1, 2, 3, 4, 5, 6. Something wrong. Yeah. Now, this is our P1 equal to 0 line. This is our P1 equal to 1. Means this width is actually considered as unity. Least probability is 0, highest probability is 1, and these are all the fractions which will be there in between. So now left side is 6, right side is 4. So here it is, here it is. Let me join these 2 points. That line is our A1 line. Line reference A1. Left side is 7, right side is 3. Let me join those 2 points. That is our A2 line. Then left side is -4, right side is 5. Join those 2 points. Then left side is -5, right side is 8. Yeah. So this, I didn't specify that A3 and -4 and 5. So this is our A3. This is our A3 line. This is our A4 line. Yeah. Now we are approaching this problem from B's point of view, and we know B is a mini-max player. Whose objective is to minimize his maximum losses. So we need to shade upward for all these lines, means shading will be like this. Now in this, we'll identify the corner points. One is this, one is this, one is these, and one is this. In this, we need to identify what is the least. Least is at this point, and we call that as P, and we may notice that P is nothing but intersection of A4 and A1. A1 intersection A4, which means player B will adopt his strategies 1 and 4 only and ignore 2 and 3. 2 and 3 strategies. So based on this, we can have a revised payoff matrix. Hence, the reduced payoff matrix will be, we will have to have a 2 by 2 matrix. So for player A, sorry, I wrote it as player B. It should be player A. Will adopt. Okay. So now player A is going to adopt only his first and fourth strategy. This fellow 1 and 2. Now, if I write those corresponding numbers, payoffs inside 4, 6, and here it is 8, minus 5. Since now it is a 2 by 2 matrix, we can go for the oddment algorithm. First one, it is 8 minus of minus 5, which will give you 13. Here it is 4 minus 6 under modulus, which will give you 2. Here it is 6 minus of minus 5, which will give you 11. Here it is 4 minus 8. Sorry. 6 minus or minus 5. Here it is 4 minus 8. That will give you 4. And we know the probabilities are for this 1 and 4, it is P1 and P4. Here it is Q1, Q2. From here itself, we can identify what is the value of P1 is the corresponding oddment, which is 13 divided by 13 plus 2. So it becomes 13 by 15. So our P4, which will be now, because remember, when you ignore, this implies that P2 is P3 and both of them will become 0 because he is not going to adopt those strategies. So the probabilities will be 0, which means now you have only 2 probabilities. That means I can say P4 is 1 minus of P1, which will be 2 by 15. Same way, Q1 corresponding oddment is 11. Sum of the oddments is 11 plus 4. So it is 11 by 15. So Q2 will be 1 minus of Q1. That is 1 minus of 11 by 15, which will be 4 by 15. Now we can calculate the value of the game. It is 4 times P1 plus 8 times P4, and that is 4 times, what is that, 13 by 15 plus 8 times 2 by 15, which will be 13 4s are 4 3s are 12, 1, so 52. 52 by 15 plus 16 by 15. That gives you 68 by 15. That will be the value of the game. So optimal strategies can be written as for A, P1 equal to 13 by 15. Sorry. 13 by 15. P2 will be 0 and that will be the same as P3. P4 is 2 by 15. And then for player B, it is Q1 equal to what? 11 by 15 and 4 by 15. Q2 is 4 by 15. That is the solution for this particular problem. In case if you find the contents of this video to be useful, I request you to please like, share it with your friends and also subscribe to my channel. Thank you.